the way the talk kind of goes is we're going to look at the performance and the memory characteristics first, and then look at the actual features. Ideally, the talk just gets over in like 10 seconds, and all of us go get like a beer or like tea, depending on the time of the day, because the answer of should I upgrade my Java, of course, is yes, and that's it. That's the talk. But what I have realized across the years is just saying yes is never enough. Like you have to justify behind the yes. And the way this talk came about was I had to do a few of these justifications a few years ago, and then I was like, oh, it just makes sense that I create sort of a ready reckoner for folks in case they want to refer to it. So with that, just a quick introduction. I'm Nikhil Nanivadekar. I'm one of the active project leads of Eclipse Collections. How many of you know what is Eclipse Collections? Okay. How many of you know what is the Eclipse IDE? Oh, good. So Eclipse Collections has nothing to do with the Eclipse IDE, okay? Other than the fact that the library is a part of the Eclipse Foundation. I'm actually a heavy IntelliJ user, and I use IntelliJ to develop Eclipse Collections and contribute to it. So that's why I said, what is Eclipse Collections? A quick 10-second blurb. It's an open source Java collections framework which comes with its own list, set, map. It also comes with its own primitive data structures and some other data structures that the JDK doesn't have, like bags, multi-maps, pools, so on and so forth. Give it a look. The website is fairly straightforward, eclipse.org/collections, or you can even search my name, or you can search the library. You'll get all the resources. Whenever I'm also a Java champion. I see there's a fellow Java champion, Ken Cousin, out there. Thanks for joining. By the way, he gives amazing talks on like testing, so make sure you all attend that, or at least look at the YouTube videos. Until Twitter is going, I'm available on Nikhil Nanivade, on Twitter as Nikhil Nanivade. The project repo, like all the code, including the presentation and everything, is available on GitHub. If you search for my name on GitHub, Nikhil Nanivadekar, then there's a repo called as Should I Upgrade My Java? So fairly straightforward. I want to give a special thanks to my friends Billy Corondo and Chandra Guntur. They did not just help me with the review of the talk, but also with some of the content as well. So with that, let's get in it. So the first one, like I said, we're going to look at the actual performance characteristics and how it impacts between different JDK versions. And normally, I've been at talks where we will go through a whole round of features and everything, and then like the measurements and the performance and the metrics and everything will be at the last, like the finale kind of a thing. I decided to change that because it's good to get that out of the way and then focus on the features. So basically, JMH stands for Java Micro Benchmark Harness. How many of you know about JMH? Okay, so let me give a quick overview. It's basically a project available on OpenJDK. You guys can search it. It's called JMH, and essentially what it does is it allows you to benchmark your code or your program, so to say, at a micro level, and then it will report. You can figure out, like you can basically set up the benchmark the way you want it, and then you can measure either operations per second or time per operations, or like some other measurements as well. A few things is for JMH, it's very important for you to set up your test properly, and since folks are unfamiliar with that, I'll actually walk through that as well. Like I know it's not a part of Should I Upgrade My Java, but hey, why not? A few things is like because it looks at the performance at a micro level. Small things like, let's say, because I tested everything on this laptop, which is a 4-core Intel i5 processor, but I tested it while it was doing nothing other than like some background OS tasks that run, but I wasn't opening like Gmail or something like that, because it's super important, as you don't want to influence anything. As believe it or not, it does influence the metrics. The few things to note about the measurement configuration. So basically, all the measurements are across 3 forks. 5 warm-up iterations and 5 measurement iterations. Now what is that? So 3 forks means the test runs across 3 different forks, and then eventually, so basically 3 different forks will run 5 measurement iterations each. So in total got 15 measurement iterations, and then they get like, collected and then averaged out, and JMH actually gives you a nice report that you can just copy paste. We do go through some warm-up iterations, so 5 in this case. The reason why you need to warm your JVM up is, as all of us know, the Java runtime will optimize your programs. So you actually want to warm up your JVM so that you give it a chance to do its job and give you the best performance as possible. So if I was in a laboratory setting or something like that, I would probably have like close to 50 warm-up iterations and 25 measurement iterations across 3 forks. But everything takes time, and the whole reason behind me putting these performance metrics together were to essentially show an indicative pattern. So don't consider that these numbers are authoritative, more of like indicative, and then as it goes for every single performance test, your mileage may vary. So at least this is a starting point for you, and then you can test out your own application. You just make sure you profile and test it, because again, performance characteristics change between every single program. The measure that is reported over here is operations per second, and obviously because you want more operations happening every second, hence higher numbers the better, or bigger numbers the better. And standard disclaimer, your mileage may vary, so make sure you test it out yourself. So how are we essentially measuring it? So while I was trying to write this talk and putting together some common patterns, I realized that because while programming and while building Eclipse collections, we do have some JMH tests that we run, because whenever we are making some changes which we think are performant, we have to justify them, right? So similarly, while I was writing this talk, I was like, what makes sense to actually, profile or performance test? Because and when I looked at the common coding patterns, it's generally data structures that we play around with. And so in this game, map and map.put, map.get. Also, a few nuances is that I used string and integer. String and integer. So string has not gone through major changes after JDK 11. And integer has not gone through any changes since JDK 8 anyways. Similar thing about the data structures like maps and everything. So new APIs are added, but essentially the performance updates that performance improvements that end up happening have not been significant or close to none for it to show that hey, because we used an upgraded data structure, that's why the performance is better or worse. It's pretty much because of the language upgrade, and that's what I wanted to showcase. So with that, let's actually look at the code. So again, I'll go through a little bit, because folks are just for the sake of completeness from what a JMH test is written like. So you annotate your JMH test with benchmark. So that's basically a benchmark, and then you have this method which is in drawing parallels with JUnit, you'll have at test. Here it's at benchmark, and then similarly you also have at before and at setup and all of those things. Now you will see a very nuanced thing over here where I'm returning something. Now the reason why you want to return something is you want to make sure that the JVM is not doing any micro optimizations, and it's actually keeping all the data structures and all the objects in memory, and it's not giving any unforeseen or unexpected side effects. So this is a cool trick. There are other ways as well to do it. If you Google JMH, if you're more interested, you'll get to know. So, but there is a particular way in which you have to set up your benchmark as well, so that you get some some proper readings or some predictable readings. In this case, I just have an array list of elements, and I go through each of them, and then I put with the same key and the value. Similarly for the string, I just end up converting that integer to a string, and then I put it in the map, and I return. And you can see I'm not returning this.elements, because that is already constructed in the addBefore method. And in the addBefore method, that is not used for measurement of your performance. Only anything that is executed in your benchmark is used. Okay. So let's look at actually the measurements, right? So how does it fare? The numbers in bold essentially show like they're better. I don't know if it is quite clear about bold or not, but in this case, JDK 17 is like, far better. You can see there are places like, for example, size of 1000 is close to double the ops per second. And you can see that it's consistently increasing, right? Now, so it's like I said before, it's kind of an indicative, it's a pattern that you're expecting that Java 17 is actually going to give you better performance, at least in this case, right? And as you can see, the deltas, like they are also like the trend is pretty much similar, okay? Like I said before, your mileage may vary. Make sure you test out your program, as well as everything is reported in operations per second. So higher the better, and the bold ones are the higher ones. Now this is where a bit of interesting things come into picture about in map.put for string. So in here, Java 11 actually performed better up till 25,000. And for the life of me, I could not figure out what was going on, because I looked at whether there were any changes happening in the string. So essentially, there is no change in the actual string implementation between JDK 11 and JDK 17. And then I looked at like, hey, whether my test is like, incorrect or whatever. I reran the test multiple times. And finally, I was like, okay, Occam's razor, it must be hysteresis, or like the simplest solution to that problem was like, yeah, it's indicative, but something is going sideways with, when it comes to like small size elements. But at least you can see that between 8 and 17, it is still higher. And that's why I say like you might want to test your own application to see how different they are. But there has not been any changes between 11 and 17 in the string, data structure. Not data structure, data type, sorry, or object. Now, going ahead on the get measurements, basically similar to before. In this case, it's the benchmark of get, and then you go over the same list of elements. In this case, I do a get and some checking, and I expect it to be available. Otherwise, I'll throw an exception. And on the string side, I just do a value of. So if you see, like really, there are multiple things going on over here, especially on the string side as well, right? Like because there's like this string dot value of call, maybe that is adding like something or the other, and it might be behaving differently. But that's the way it is set up. And if you look at the measurements, pretty much again JDK 17 for integers performs consistently better. There is one like blip at 25,000, but I'm just going to call it as an outlier and not worry about it too much. But similar to how it was for map.put, for map.get as well in strings, you see that like 1,000 to 25,000, JDK 11 is actually performing better than 17, and then 17 performs better from about 25,000 onwards. And again, these are indicative, not authoritative. They're like showing you the pattern. So if you're on 8, like even going to 11 is going to give you performance gain. But if you're going to take the pains to go to 11, just bite the bullet and go to 17 in my opinion. So with that, we are going to switch to the memory test. So I decided that, hey, I need to create the most trivial program ever, and basically figure out a way in which I can check how much memory is essentially used, right? For the sake of, and basically what I did was I took like 3 data structures, our favorite ones, list, set, map, populated them with some size, and then looped it 5 times, and then checked the memory for every single iteration. And I had actually hooked it on a profiler as well to make sure that, like, hey, whether the GC was getting triggered or not, because I didn't want it to be additive for, every single iteration. Like, I expect it to be garbage collected as well. And it was happening. But for the sake of representation, only the measurement after the 5th iteration is reported, just for, ease of presentation. But all the code is already there in the repository. You can, open it and play it. The measurement is reported as used memory, which is essentially total memory minus free memory, and you get total memory and free memory, like those handles, Java already gives you that. Of course, because it's memory, you want it to be used less, hence smaller numbers are better, and I've used the same laptop for it. So let's look at my trivial piece of code, right? 3 data structures, string list map, map list set. I go through and the other day I was presenting, someone asked me like, what is this, like, some voodoo math going on out here? It's just because, I was incrementing from 1 to 1 million, that's it. And then there's the math.pow, and like, I don't know why I wrote it at that time, instead of just putting it in a list or something like that, but that's what I thought of, and maybe I'll go refactor or not. But essentially it goes through and I keep on printing, and then I print the memory utilization. And as you can see, for every single loop, the new map and list and set is created. So I expect the old ones to actually be garbage collected, and they were being garbage collected. Looking at the measurements, as you can see, JDK 17 is performing consistently better. The last one, again, is an outlier where it's like close enough between 11 and 17. And that's obvious because, like, nothing has changed from a memory footprint perspective between 11 and 17 per se. Between 8 and 11, there have been significant changes. So the data also shows the similar trend as well. Okay. Just to summarize, 17 consistently performs better than 8 and 11 for map.put as well as map.get for integers. For map.put on map.get for strings, we saw that like it performs better for higher numbers. The lower ones, I'm just attributing it to hysteresis. It consistently uses less memory, as we just saw. Again, standard disclaimer, your mileage may vary. Make sure you performance test it as well as profile your application. And I'll keep on saying this, like the stars conditions apply, because I suddenly, like, someone will like tweet saying that like, hey, we used this and now ours is not like performing the way you told it's performing. So that stars conditions apply holds true all the time. Okay, before I get into features, I want to pause if there are any questions. Right. I know it's the second to last talk of the day, but so generally when there are no questions, right, I believe that like either I'm doing a stellar job or I'm doing an absolutely bad job. I'm a very positive person, so I'm doing a stellar job according to me. So with that, we'll go to features. So normally, I mean, I was like being torn about this, whether should I just start all the features from 11 onwards, but then I realized like, hey, 8 is still like pretty heavily used, so it makes sense for us to baseline from 8 onwards. So that's why the way the features are set up is like only GA versions are shown, and in parentheses you will see the version in which the JDK version in which it actually became generally available. So the first one is var. It was released on as a part of JDK 10. It essentially is a local variable type inference, and what it does is it tells the compiler that like, hey, figure out what the type is, don't make me type it. That's pretty much it. It can only be used for local variables when there is an explicit initialization, and we'll look at the code sample and it will be a bit more clearer on that. The interesting thing of it is like Java is not like the first one to release such a thing. Like Kotlin has it, Scala has it, and TypeScript, JavaScript, all of them have it, and it's just like Java coming close to or Java basically supporting that same feature. So if we look at the first line of code where it's map, and map is equal to map.off, it's an explicit initialization. So you can replace the same thing with just a var. You don't have to type out this explicit type definition, and it just makes your code terse. I personally don't like to use var because I'm more of those where like I'll just type out that type it because I read code more than I write code. So I generally like to make sure that I have like my types handy and available, and I don't have to always infer or refer or something like that. IntelliJ does a great job when you're debugging to actually show you what the type is and the hints and everything, so that's pretty cool. There are a few things that I want to draw your attention to. It can, like var cannot be used when the variable is initialized to null. That's because null is essentially not a type, so the compiler can't figure it out. It cannot be used to assign lambda expressions. Okay, And lastly, this is very important, and this is a personal recommendation. Avoid using var with polymorphic code. The reason for that is, in like while like debugging and everything, I figured out that it's super difficult for you to trace back, like in polymorphic code when var is used, as to which exact type it is. And the only way for me to do that was like actually hook on a debugger, figure out, and then infer the types. So please do yourself and your fellow developers a favor by not using var with polymorphic code. Any questions on var? Okay, next one, updated switch statements. This is one of my favorite features of Java. I mean, this is like amazing, because how many of you use switch statements? Okay, most of you. How many of you know about the updated syntax? Few of you. Awesome. Sorry, go ahead. Okay, awesome. So I'm going to enjoy explaining this. So basically, the updated switch statements were launched as GA as a part of JDK 14. It can be used as an expression in order to yield a value. And we'll actually look at the code examples when it will become much more clearer. And it's very important to understand for it to yield a value. Okay. A case statement in the updated syntax can actually contain multiple values that are comma separated, and we'll look at that as well. A new restricted identifier was introduced called as yield. The yield syntax basically says that like, hey, I'm going to yield the program and return this value, kind of a thing. Switch can now be on enums. Switch expressions need to be exhaustive. We're going to look at what exhaustive means as well. Essentially, it needs to cover all possible scenarios. And a switch expression must always yield a value or throw an exception. All right. And switch is also being worked on, as well as new features have been introduced even in the updated switch statements as well, with like switch and pattern matching and all of those things, and it's super cool. So I'll keep on adding more over here, but let's quickly look at the old style of syntax, right? So it's a simple function. Basically, pass in a month number, return what quarter it is. So 1, 2, 3 Q1, 4, 5, 6 Q2, so on and so forth. Like 10, 11, 12 is Q4. Now you can see it's like pretty much the same thing. It's redundant code which keeps on going over and over again. And then essentially for default, we are just returning that it doesn't happen. Now with the updated switch expressions, what ends up happening is everything just collapses now, because all the redundancy is changed by the comma separated conditions. So for 1, 2, 3, it's one line which is Q1. So all of that. And then the lambda syntax that is there, that's basically equivalent to you returning a value or you yielding a value. Okay, and then now you can even as an expression, because it's an expression, it can stand its own ground. Hence, you can even store it as a variable. So that makes it pretty cool. For switch with yield syntax, essentially, because now you can actually convert these into code blocks. So if you look at the last one where, hey, I want to do something for that particular case. So you can convert that to a code block, but whenever it's a code block, you have to yield what the value is. All right. So and in this case, I'm just printing out something to console. That's it. Now the last one is switch with enums, and this is super cool. And I personally like using enums a lot, because it just makes the code much more cleaner. It reduces the number of bugs. It makes it much more maintainable. And someone asked me the other day, why does it make more maintainable? So this is a classic example of why it makes it much more maintainable, right? So we got 12 months. All 12 months are covered out here, right? That's the reason why there's no default statement, because this switch case is actually exhaustive. There is no 13th month out there. Hence, you don't need a default. But now, let's say something happens and we have a 13th month, right? That time, this is going to throw a compiler error. It's not going to just return default, something like that. So now I actually have a safety net, because hey, the program itself won't compile, right? Now this is a very naive example about a 13-month coming, but you all can understand what I'm saying. And I have seen multiple times enums actually be used properly in this case, because it makes your code much more extendable, much more maintainable. And then for you to extend, you don't have to worry about tracing where all it is used and everything, because the compiler is actually telling you that, right? Any questions on switch statements? All right, moving on. The next one is text blocks, introduced in JDK 15. This is another of my favorite features, mainly for its convenience. That's because prior to that, we had to deal with these unwieldy, long JSON, string concatenation, and I don't know how any of us were able to even read that code, because the /ns and the escaping of the double quotes, especially in JSON string, was like unbelievably unmaintainable as well as incomprehensible. To the fact that like I used to be, I use IntelliJ's in injecting code fragment feature quite extensively, because how many of you know about that? All right, I can even show a live demo if we have time, but essentially what IntelliJ allows you to do is, for a particular statement, you can Alt-Enter and insert a particular language out there, and JSON is like one of the languages. Because you insert that, like you actually get a separate editor where you just type your string and IntelliJ figures out the actual JSON representation, and it does it for you. So you don't have to do it, and you don't have to figure it out. And I was a heavy user of that, to the fact that some people on my team said that, how are your JSON strings like perfect and like every single time? And when I showed that to them, they were like, oh, we did not know. It's super cool. I'll show that as a quick demo towards the end. But basically, coming back to the text blocks, it's an alternate representation of a string. Okay, just because it's a text block, that does not mean like, hey, this is a new type of a string. It's just a representation. So everything that applies for string applies for text blocks as well. It is mainly to improve readability and clarity of code. And there's a nice blog called as Programmer's Guide to Text Blocks. It actually covers these things in a lot of detail. And on my repo, like these all links are there, so you all can click around. So looking at it, it's the long string where you got all the escapes, you got all the /ns, and it's basically Nikhil and Seattle, just 1, 2, 3. It's fairly straightforward. Now, if you look at the new style of code, it's basically just that. It's much more cleaner. So the 3 double quotes at the start tell Java basically that like a text block is starting. The 3 double quotes at the end say that like it's ending. And the beauty of this is Java will actually understand that like, hey, this is a text block, and it will honor everything, all the tabs, all the spaces, and everything that you have put in there. So you don't have to like you don't have to worry about like, hey, a formatting that you have put in your code is going to be different than the representation that is coming, because that sometimes like is fairly important on that front, right? Then someone will ask, hey, but this is when you know the actual values. Like I know Nikhil n. What if it's variables, right? In that case, you can use the formatted syntax where you can have the placeholders, the %s's and the %d's, and then you just say your text block dot formatted, because string got the new method on it, and that helps you do the same thing where the Nikhil and Seattle 1, 2, 3 will be substituted at the appropriate places. Okay, does that make sense? Any questions on this? Next one, as a boon to all developers on call, I would say. It's called helpful null pointer exceptions. And I remember the very first bug that I introduced in production was a null pointer exception, because guess what? I missed the null check. And it was so difficult for me to isolate what exactly was null. And I wish this was available at that time, because for the life of me, I could not figure it out. And then I had to figure out creating a reproducible use case to understand like 3 levels down something is null, like those aha moments, right? This is there to actually reduce those aha moments and make it much more easier, because in chain method calls, it's always difficult, because let's say you have one method calling another method calling another method. If any one of those are null, you will get an NPE. But you don't know which exact call returned an NPE, and then you have to sleuth yourself around to figure out what exactly is going on. A few notes is that it only prints out these helpful null pointer exceptions when the JVM throws it. If you throw new null pointer exception, then it won't throw the helpful null pointer exception because it's your responsibility at that time. So looking at it the old style way, it's simple. It's just an object, Nikhil n, and then the next one is address, which is null over here. And you can see here this get address and get city and get dot to lowercase is the chain method call. When there's an exception, it only says that like, hey, there's a null pointer exception at line 13. Go figure, right? But now in the new style, you can see that like it's much more helpful. It tells you that address.city cannot be invoked. Address.city cannot be invoked because person.address is null. So it's up to that granular level detail, and that's super helpful. All right. And continuing the same example, let's say I had the address object, but my city was null. In that case, it says that like I cannot invoke string dot to lowercase because city is null, right? Now this also creates something that I want to draw awareness to. Because it is so well detailed, your variable names are actually going to be in your logs and everything. If your logs are not protected, if you have sensitive variable names, they might get exposed. So make sure you're cautious about these things, and I hope everyone's logs are protected, behind some entitlement. But that's something that you need to be aware of, and also make sure that your variable names are not sensitive. Any questions on helpful NPs? Yes. Yes, the question was, is there a way to ask the compiler not to use it? So there is a flag which is by default on, but if you want to turn it off, you can pass in yes. Yes, so I mean it's possible that in production you don't want to print them, but in all other environments you want to print them, or like however you want to do. But yeah, you can pass it. But the config is there for the whole program, so it can't be that like for just one invoke, like for this one class it's sensitive, that's why I don't print it. For everything else you don't get that option. So any other questions? The next one is pattern matching, for instance of another of my favorite, let me be very frank about, I've only covered my favorite features over here, but there are like a ton of other features that are added. I had to pick and choose the ones that I use and I like the most. So that's why it's only like 6 or 7 that are covered over here. So pattern matching of for instance of, it allows conditional extraction of components from objects, and we will see in code what that exactly means. This yields you to have like some concise code written and much more clear, and it removes casting. And all of us know how bug prone as well as how unmaintainable casting is. The pattern matching of instance of also adds a bit more of protection in terms of essentially scoping the variables properly, and we'll see what that means as well. There is, I don't know if it was launched or not, I need to like double check, but now the updated switch statements and pattern matching, you can use both of them together, and that makes it much more powerful. I just don't know whether it's GA yet or not. It's not, thanks Ken. But presumably it will be soon, and hopefully for 21. But that is going to be like super powerful, and I mean I love both of these features, and like both of them commingled will be amazing. Some languages like Haskell, C# already have it for its terseness and brevity, and Java is just like following suit with that. So let's look at the old style of code where you have instance of string, then you cast it to a string, and then you do something with it. Similarly for integer, similarly for double, right? In the new way, this all just makes it much more terser, and you can see that the code block is actually like smaller as well, where in your if condition, if the input is an instance of a string, then what you're telling with this updated syntax is store it in the variable called a string. Okay, so over here, because my input is an instance of a string, store the value of input in a string, and now you just use a string everywhere. And the thing is, the scope is only within this if block, so it won't leak into the next if block, and that's very important, and that's pretty neat. And it makes sure that like your code branches and everything are like nicely well laid out, and you have execution safety as well. Okay. So the next one is records. Any questions about the pattern matching before we go? Okay, perfect. I'm doing a stellar job. The next one is records. They were introduced as GA on in JDK 16, and it's Java's way to allow you to essentially model data classes in Java. I think many folks end up using a popular open source framework called as Lombok, just because it reduces the boilerplate code and everything. I personally don't like to use Lombok. Sometimes I use it if I have to, but essentially with records, I don't think we will need to depend on Lombok as much as folks do right now. Basically, prior to records, there was a lot of boilerplate code, especially in terms of the constructor, the accessors, the hash code, toString, like all of these methods that we had to write. I used to use IntelliJ to code generate them, or use Lombok, so to say. For records, all the fields are private finals. They are shallow immutable. Shallow immutability is it's an interesting concept. We can discuss about it later, or you can even Google it, and it's fairly well covered. It allows you to essentially mutate but not mutate, and it's quite interesting. You cannot declare instance fields in records, and like Java will actually create default implementations for all the accessors. The hash code equals toString, as well as the constructor itself. In case you want to override it, you can override it. You get the ability to do that. In case you want to add more methods to it, you are allowed to do that. So it basically gives you a nice, this data-oriented programming, sort of gateway. There's a nice blog called as Data-Oriented Programming in Java. I don't quite remember who the author is, but I think it's one of the Java architects, if I'm not mistaken. But it's a really great blog. Make sure you read it. So let's look at the old style. So person, non-record, you got private final string, first name, last name, and because I had to fit it in one page, I have not written the constructors, accessors, hash code equals to string, but I would have to implement that. With records, all of that just pretty much goes away, and now this is pretty much my constructor and my definition, where by default it's going to be a private final string first name, private final string last name. Okay, the getters are automatically created, so you will get a get first name method created by Java itself. And as well as hash code equals toString. In this case, I'm overriding the toString method because I want to do something different. I think I add like some comma or like remove a space or something like that. And this is the custom method that I wanted to add, which is get full name, where it's first name plus last name. All right, so this sort of shows. By the way, all of this code is available on the GitHub repo. So if you want to check it out and play with it, you can do the same. The last one in terms of features is sealed classes. This improvement in the JDK with JDK 17, it's kind of a boon for library developers or library maintainers, because what Java did was it gave us an ability to control which part of the hierarchy of the inheritance hierarchy we expose and allow for extension. Because prior to sealed classes, any non-final class could be subclass. And as like I mentioned before, I'm the active project lead of Eclipse Collections. We had some folks just extend our lists and sets, and then they would be stuck having to implement like 70 odd APIs, and they would complain that why do you have so many APIs? And we would go why are you extending our implementations? If you have a need, raise an issue or something like that. But essentially, it never gave us any control to not to prevent anyone from extending these non-final classes. So just looking at what exactly do sealed classes bring. So sealed classes introduced modifiers and clauses. So the first two are essentially the modifiers, which is sealed and non-sealed. So sealed basically tells that like, hey, this class is sealed, no one else can extend it other than the classes that are permitted. So that's why there's a permits clause that was added. So unless another class is permitted to it, no one can extend it. The non-sealed classes essentially allow for any class to extend it, and it will open up that side of the hierarchy, but only through the non-sealed classes. A few things that I learned while I was preparing for the presentation, which is worth a note, is even if the subclasses are in different files, but they are in the same module or they're in the same package, you still need to specify the permits for sealed classes. Okay. However, in case you have all the classes in the same file, you don't need to have the permits clause, because by default everything gets opened up in that one file, in that one Java class, in that one .java file. And this I learned because, like I said before, all the code actually is runnable, and I was expecting it to not run. And that's when I realized, like, hey, this is the situation. And when I dug a bit deeper, I realized this is a feature. So that's why permits is, so just be careful about that. Let's quickly look at the class diagram in the code so that it clarifies what's happening. So user, it's denoted by dashed lines. That's my interface. But because it's dashed line, it's essentially sealed. The solid lines are final classes. So owner is a final class. The dashed lines are sealed classes. So admin is a sealed class, which only permits super admin. That's why that arrow is valid, but it does not permit a temp admin. Even though the temp admin so strongly wants to become an admin, they cannot. So that's why it's crossed. Resident, it's a dotted class because that's a non-sealed class. That's why that side of the hierarchy is opened up. So you can have day guest, overnight guest, so on and so forth. All right, and that way, for day guest and overnight guest, the inheritance is actually opened up via resident. But admin only allows super admin, right? And this gives you control, because let's say I only want to open up one part of the hierarchy, I can do that. I don't have to expose the whole thing. So just looking at the code, this is how the code looks, where it's an interface. The name is user, it is sealed, and because it's sealed, it needs to permit, and it permits owner, admin, and resident. And I just created a default method for testing purposes where I wanted to make sure that the code was actually working. In terms of the actual inheritance, owner, admin, and resident are the three implementations. Owner is the final class, and as you all remember, user permits owner, admin, and resident, only these three. So over here, this is final. Owner is a final class. Admin is a sealed class. So we got another sealed one, implemented. Which is implementing the sealed interface as well, and it is only permitting super admin. So if you all remember the class diagram that was written, the only super admin was actually allowed. Resident is the non-sealed class, and it implements user. So just looking at the class hierarchy again, in terms of the sealed classes, this will allow the sealed class admin permits only super admin, hence this test passes and it actually works, whereas the temp admin, this won't compile because it's not permitted. Okay. In case of the non-sealed classes, the non-sealed class resident implements user. So now this is available for extension for subclassing as much as you want. So essentially, day guest extends resident, overnight guest extends resident. If I had another class called Nikhil, it can still extend resident, no problem with that. Okay. Any questions in sealed classes? Yes.
What is the use of non-sealed classes like former classes?
Okay, so the question was, what is the use of non-sealed classes? So essentially, if you have a sealed class, and then you have so you can have a final class, right? But you can either have a final class, you can either have a sealed class, or you can have a non-sealed class. Now, the reason why you would want to have a non-sealed class is if, let's say, there's a branch of your inheritance hierarchy which you actually want to give to your consumers or your users to extend, then in that case, you need to specify that. That's the only reason. Like I don't have a concrete example to give you for non-sealed classes, but it will essentially, that's Java's way of allowing you to open up your hierarchy by doing non-sealed classes. Any other questions? So the question was, what if you don't mark a class as sealed or non-sealed class? It will behave exactly how it was before. Only when you add sealed, sorry, go ahead. Yes, oh, by default, it's a non-sealed class unless you specify it's sealed. So because prior to getting the sealed modifier, you had either final or you never type non-final, right? It's the exact same thing. So it's by default. Any more questions?
Can we generate,
Yeah, you can.
then we are waiting, waiting process.
What do you mean?
That will be accepting the question mark and then we can edit it.
So the question was, will it accept generics? And if it did, it will break the pattern. Let's take this offline because maybe we just look at the code and then you can explain me what the question is, because I'm not following. So we'll take it up. And I have time. I've got 15 minutes. I'm almost towards the end of the talk. Any more questions? Okay.
The benchmarking Java 8, 11 and 17,
Mm-hmm.
the JDM settings use all the same?
Yes. So the question was for the benchmarking slides, the performance slides that we used. Yeah, there were no, were there any changes in the, I'm just repeating it for the video because, so were any of the, during the,
GC settings or heap settings, any changes?
yeah, let me repeat the question for the video. So basically the question was for the benchmarks, were there any changes made in the runtime configurations, like GC settings or anything, or it was just default? It was just default. Like there were no changes.
Defaults might have changed, right?
Yes, so some of the defaults did change, but I think the GC defaults change and everything like that. But essentially, I mean, I did not force it to behave in a particular way. That's the whole point. Yeah, so that's what I'm trying to say. Like I did not force it to behave in a particular way.
By default, it might have changed.
Yeah, 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 yeah. Okay. No, not Z1 is not yet. We'll look at that in a second. Along with some additions, there were some removals as well. Some of the most important ones to call out is the first one is the Nashon engine. So Java came with its own scripting engine. It was called as Nashon. It got removed from the actual JDK and it spun off as a separate project, and it comes as a own Maven dependency and everything like that. So and it was actually for the better, because I think the scripting engine with Nashon as a independent library actually provides much more flexibility. The CMS garbage collector did have its nice long run, but it was removed as a part of JDK 14. With JDK 17, since the sealed classes were already introduced, it also gave the opportunity to encapsulate the internals, because previously you could go and play with the actual JDK internals, you could access them and everything. Now they're like strongly encapsulated so that even with reflection you can't access them. And there were a lot more deprecations between 8 and 17, but these were the three important ones that I thought I should call out. I mean, I know that, has anyone heard of something called as Corba? Okay, no, Corba. So, but no one has, so I think I'll save you the pain. So looking at garbage collectors, these were the ones that exist now. Serial GC, Parallel GC, G1 GC, ZGC, Shenandoah, and as well as Epsilon. Epsilon is experimental as of September 2022. ZGC is not a default for any of the JDKs. At G1 GC is the default one for 17. If you want any of these GCs to be used in your program, you basically pass in the flag to tell which garbage collector to use, and then Java will use it. Also, GCs are its own complete field, which and warranting its own, respect as well as research. And there is enough online material, as well as we have a lot of talks as well given by folks in the community. So take a look at that.
People say that GWC is an auto-tuning
Mhm.
garbage collector. Is it really true or is it fake?
In my experience, I have. So the question was, folks say that G1GC is an auto-tuning garbage collector. How true is that? In my experience, I have had good mileage with that. So, but again, your mileage may vary. Lastly, to close out, as a part of takeaways, so there, from 8 to 17, there have been performance improvements. There have been new features that have been added. Like I said, at the start of the talk, and I said that, hey, the talk will get over in 10 seconds, make sure you upgrade to JDK 17. And it's not just about upgrading to JDK 17, it's also 17 is already more than a year old. And it was released in September 2021, right? The next LTS, which is JDK 21, will get released in September of this year. So if you're already not on 17 in September, you will there'll be another talk by Nikhil saying that should I upgrade to JDK 21 for the next gigs. But it's essentially that's how we are, because with this rapid cadence and release schedule, you have to embrace that change. You have to embrace doing upgrades, right? It's not something that you're just because 8 is still there's still some support available, etc., etc. We are already using it. That doesn't no one is stopping just because you haven't upgraded. So make a case that hey, let's upgrade. Embrace the future. That's all I would say. Embrace the future by using all the features. So with that, this is the end of the talk. Happy to take more questions, concerns, even have a chat. But really, thanks a lot for spending the afternoon with me. I hope you all had an amazing Great Indian Developer Summit. It's one of my favorite conferences to come and present at. So thanks a lot.